Hello, good morning, dear students. Today we will see the I/O architecture. What actually the I/O architecture contains? Since starting of this unit, I am telling you that this is a system on chip, system on chip, system on chip. Quite obvious. When I say that it is system on chip, we have to look for each and every factor which is associated with the chip design. And I talked about clock, I talked about power, okay, these issues I talked. Now I'm going for another thing, that is an I/O architecture. Whenever I say I/O architecture, I should say little about the packages also, because why we go for packages, what is the purpose of package. You can see any IC comes with a package. Let us say most commonly known dwell in line package or DIP package. You might be knowing that what package provides to an IC. Actually, package provide to an IC a mechanical strength. This is being provided by package. Also, package also helps in distributing the you may say power. Actually not power. Actually, it is a heat dissipation. Heat dissipation. This function also being provided by a package. The another function which is being provided by package is ease of using or simplicity in using the IC, because it is not possible for anybody to solder a core over there. That's why whenever the IC is being rather I should say a core is being with a package, will give you the flexibility in using it anywhere, and you can have a connection to the different circuits also, because it will give you the leads to that IC. Okay, hence we will study now that what an I/O architecture is over there. I started it I/O architecture without a package. That's why I first told you that what a package is going to give. Can you recall the things what package will provide? The first thing the package will provide is a mechanical strength. The mechanical strength to a core logic is being provided by package. It will also helps in heat dissipation. The heat will be dissipated through the package also, and also it will give you the flexibility in connecting or easiness in connecting to the circuitry, or it will give you the way you can solder or you can have a connection to that IC anywhere or not anywhere on the circuit. This you can have the advantages of package. And inside a package you may say there is one point, that is an I/O architecture. Okay, and here it is a what we are going to study over here, that what is an I/O architecture. In I/O architecture, I told you that there is a core logic, and with the core logic you have certain pins. Some pins may be used as input, some pins may be used as an output. And if you use any pin and output input, then what are the requirements? And if you use any pin as an output, what are the requirements? That's why when you use any I/O pad, then their associated drivers are distributed around the edge of the chip. It should be over there. Advanced high density packaging schemes devote a layer of metal to pads and distribute them across the entire chip face. You will see that the pads are being distributed over the edges of the chip. This is in a high density chip, this also happens. And each pad must be large enough to have a wire or a solder so that it can be soldered. And it must include input output circuitry as appropriate. It is inside the package, or inside a package or inside the I/O architecture. It should have a certain circuitry for an I/O architecture. Here this will tell you the pad frame. Okay, here internally, if you see that internally, you will find a core logic and surrounding to the core logic you will have a pad pins. These are the IO pads. This pad frame, each pad is built with the standard width and height for simplicity. Each pad has large VDD and VSS line running through it. The pad includes large piece of metal to which the external wires are soldered. This is also one function of pad. And the pad requires external circuitry, and it is usually put on the one side of pad and closest to the chip core. The chip core fits in the middle of the pad ring. This is most, and actually it is being supported by the package. Okay, all these things is being supported by the package, and pads are at the edge of the packages. This is the thing, that pads are always at the edge of the placement of pads around the ring are usually determined by a required order of pins on the package. That's why you can see that the DIP package, okay, then TO, different types of packages are over there. Okay, the wires to the package cannot be crossed without a danger of shorting. Whenever you have any wires, okay, this cannot be short without a danger of shorting. If so, the package pins are required. So if the package pins are required in a certain order, the pad must be arranged in that order. See, in most of the cases we will find that some port pins on the take an example of microcontroller, you will not find all the port pins on single side. It may be on both the sides also. It is arranged as per so that there will not be the crossing. There will not be the crossing of wires on the package or pads. This is the care has been taken. The pad is much larger than any single wire connected to it, so that current in each direction is limited by the outgoing wire. If we want to use multiple power pins to limit the inductive voltage drop, which we have seen in the earlier case, that supply and ground bounce. That's why what we do to reduce the supply and ground bounce, we use multiple power and ground pins. Thus we can use several VDD or VSS pads around the ring. Now we will see the pad design. Actually, pad design means how to design and what are the requirements. Here I will say that pad designing means you go for what are the requirements of input pad and output pad. That will be the better thing. Okay, pad is used for input and output signal, require different supporting circuitry. For example, if you give an input, it will directly go to the inside transistor or a core logic transistor. But if you take an example of output, the output doesn't go anywhere to the internal circuitry. Rather, you may say that it is a load, it's connected to the load, and load may be a capacitive or a resistive load. Okay, a pad is being used for both the input and output, and sometimes known by its trade name, that is a tri-state pin, and combines the element both input and output. Sometimes the pad may be the input or output pad also. Input pads. The input pad may include a circuitry to shift the voltage level, otherwise condition of the signal. The main job of an input pad is to protect the chip core from static electricity. Now you try to understand, this is a very important thing which is being performed by input pad. Input pad has to protect the chip core from static electricity. The people or equipment can easily deliver a large static voltage to the pin when handling the chip. You might be remembering that whenever at the time of practical, I always say that don't touch directly with your hands to the IC. Why? because your body may have certain static charge, and that static charge may damage the MOS circuitry, because our most of the ICs are made up of MOS, and the MOS is very much sensitive to the static discharge, and because of this static discharge the thin oxide may get damaged. That's why whenever you are designing an input pad, or input pad should do, or it has to do the work of protecting the core logic. The gate oxide, which may be a very small, few angstroms thick, it is a 10 raised to minus 10 meter thick, and can be totally destroyed by a single static volt. Actually it is a print mistake, it is not JOLT, it is VOLT. Okay, shortening the transistors gate to the channel. An input pad puts a protective circuitry between the pad itself and the transistor gate in the chip core. The electrostatic discharge, that is ESD, can cause two types of problem: dielectric ruptures and charge injection. Actually dielectric rupture is of the just breaking of the transistor, the SiO2 layer is get damaged, and it may happen that whatever the charge which is over there on external device or a person will get transferred, or the charge will be injected inside the MOS. Output pad doesn't have to do these things. What is an output pad? The electrostatic discharge protection is not needed for an output pad, because this output pad is not connected to the transistor gate, that is the next transistor gate. The main job of an output pad is to drive the large capacitances seen by the output pin. This is about the input pad and output pad and IO architecture. You just remember about this lecture is that what is the purpose of the package, why packages are essential, what are the different types of package, and what is an IO architecture, and what is the input pad, what are the requirements for input pad, and what are the requirements for output pad. Thank you very much.